In this lesson, we will consider different data visualizations in R. We will look at a bar plot, a pie chart, a histogram, box plot, scatter plot, and a line plot. We'll also discuss various options we can have with each of these plots. So in this lesson, we're going to talk about data visualization in R. And before we jump into it, I want to tell you I've changed my layout here in RStudio. The panel down here in the bottom is the general panel, and I did this just to make it a little easier to see the plots. The environment panel and the console panel are still here. You're just not going to be able to see them on the screen. So let's jump right in. We're going to start off by calling the reader package, which facilitates the importing of data. Now we'll pull in a data set here in just a moment. The data set consists of insects that are trapped. So we have 5 variables: the trap identifier, the number of honeybees trapped, the number of wasps trapped, the number of hornets trapped, and the number of other insects trapped. I'm going to pull in my data. I'm using my read.csv command here. I've got a Dropbox link that I'm using, and I'm going to call the data here insects. And so let's start by just taking a look at the data set. So you can see the variables here, and we've seen this data set before. Now we're going to look at some data visualizations with it. Before I do that, I'm going to attach the data set to the workspace. And remember what that does is that it makes those variables in that data set immediately available for R. Now we'll start with a simple bar plot. And bar plots are used when comparing measurements between groups. We're going to use the bar plot to take a look at how many wasps there are in each of these traps. We will use the bar plot command. And we see what that did was that just gave us a simple bar plot. Now let's talk about some different options you can add. We're going to add the category names, and we'll do that with the names.arg option. Arg stands for argument. So the names.arg option will just be a data array that consists of the names that we want to put in for these various categories. We could create a data array that consists of A, B, C, D, E, and F. Make sure you put all of those in quotations. And when we run this, we see that that just labels each of these different categories. Another option here is that I could just have names.arg equal to trap. Remember that trap is a variable that consists of those different names: trap A, trap B, trap C, and so forth. So I could just set names.arg equal to trap. I can also add a graph title with the main option. I'm going to set the main equal to wasps collected. And just like we do with all text strings, we're going to put that in quotation marks. And so we've got a graph title. Another option we can set will be the color, and we'll do that with the COL option. And we'll just set that equal to the color name. Now you can find R colors pretty easily if you just do a Google search. Then you'll find all kinds of options here. So I'm going to use the color Dodger Blue, and let's take a look and see what that looks like. Other options that I can add will be the X label and the Y label, and so I'll just set XLab equal to trap identifier, again that's in quotations, and YLab equal to number of insects, again in quotations. And let's see what this looks like. Now I'm going to make things just a little bit fancier. I'm going to install a package called R Color Brewer, and this package provides a number of predefined color options. And you only need to run this one time. I'm not going to actually run this command because it's already installed for my instance of R. So what I will now do is call up the R Color Brewer package. If I run this command, display brewer all, it will show me all the color palettes that are available. Okay, so let's make this a little more easier to read. And so at this point, you can just go in here and choose your favorite color palette. You'll need to take note of the name of it. I'm going to use Pastel 1 in a few examples. So the way to use this is that for the color option, we will set it equal to brewer.pal, that stands for palette, and we will put in a number and we will put in the name of the color palette that we want to use. The number here refers to the number of colors used. The minimum is 3. So let's take a look at the bar plot. Now all of these other things are exactly the same: the wasp, the names.arg, the title of the graph, the X label, and the Y label. But for the color option, we will set that equal to brewer.pal, where n equals 5 and name equals pastel 1. And we've got a nice looking bar graph here that would be suitable for publication or in a presentation. Okay, so let's look at another way of displaying qualitative data. And that's with a pie chart. This time, we're going to look at the number of honeybees in each of these traps. Now we'll just use the pie command here to draw a pie chart. We can add the labels with the labels option, and I'm just going to set labels equal to the variable trap. How about we add a main title? Here it's going to be honeybees collected, and I'll set a color option here. Here I'm going to use pastel 1 with 6 colors. And we've got ourselves a nice looking pie chart. Now note that for both of those types of graphs that we just looked at, the bar chart and the pie chart, we had qualitative data and we had already organized that data into a frequency distribution. Well, now we're going to look at some quantitative data. So let's import some data about antibiotic use in hospitals. In a study, the duration of hospital stay was compared for patients who were prescribed antibiotics and patients who were not. Here we have 4 variables: the duration of hospital stay for those on antibiotics, the temperature at admission for those on antibiotics, and then similar variables for those who are not on antibiotics. I'm going to use my read.csv command here with a Dropbox link, and I'm going to name this dataset HOSP. So let's take a look at this. So we've got our 4 variables: DUR underscore antibiotic, temp underscore antibiotic, DUR no antibiotic, and temp no antibiotic. So let's go ahead and attach our dataset to our workspace. I'm going to create a simple histogram for the variable DUR underscore antibiotic, and we'll use the hist command. So R will choose the number of classes to use to produce an appropriate histogram. We can use many of the same options that we've seen earlier. Here I'm going to use the main title, Duration of Stay for Patients on Antibiotics. I'm going to use the R Brewer package for the color, where n equals 5 and the palette name is pastel 1. I will also label the x-axis as duration of stay and the y-axis as number of patients. Let's take a look at it. Now one thing to note here is that the different colors don't really mean anything in this case. I'm just choosing it because I like the way it looks. One option that may be useful is breaks. This option defines the number of breakpoints in the histogram. In the one that we're looking at here, there are 6 breakpoints that R automatically chose. Now we can specify to R how many breakpoints we'd like. I will warn you though that R doesn't always follow the suggestion. It really comes down to how nicely the range of data values can be broken up. Here I'm going to use breaks equals 4. And you can see that although I specified 4 breaks, R actually only gave me 3, but it's trying to make me happy. How about we change the number of breaks to 20? Well, I'm not going to count up to make sure that there are actually 20 breaks here, but you can see that R certainly included more breaks than there were before. Now, a traditional histogram will have frequencies on the y-axis, but sometimes we may want proportions instead of frequencies. And we can do this by including an option, freq equals false. And what that does is tell R that we want to have proportions instead of frequencies. You may notice here that I've changed some other options as well. Breaks is equal to 6 in this command, and the R Brewer color palette that we're using is the one named paired. I've also changed the Y label to be proportion of patients. Let's take a look at box plots. Now, a box plot can be useful for identifying outliers and skewness in data. So the data I'm looking at here is duration no antibiotic. I'm going to do a box plot just with the box plot command, and I'm going to use the main title duration of stay for patients not on antibiotics. Now I'll be honest, I don't really like the way this box plot looks. R automatically does vertical box plots. So I'm going to include an option here, horizontal equals true, which will turn this into a horizontal box plot. Also, I'll change the color to light still blue. And there's a couple of other options here I'm going to use. PCH stands for point character. Now again, a quick Google search will show the various options here for PCH. The one that I mostly prefer will be number 16, which is just a closed dot, but you can choose whichever one you like the most. So I'm using PCH equals 16. I also have the command CEX equals 2, and honestly I don't know what CEX stands for, but it's sort of like a font size for that symbol. And you can just play around with some different values here to see how that changes things. Let's take a look at this box plot. Now from this box plot I can see that I have an outlier. When I look at the box itself, I can see where the first quartile is, where the median is, and where the third quartile is. I can also see here that the median is much closer to the third quartile than it is to the first quartile. Now you can also see the lower outlier boundary and the upper outlier boundary, and anything that falls beyond those, we'll call it an outlier. In this case, the upper outlier boundary is further out than the lower outlier boundary, which again suggests that this data set is skewed to the right. Now suppose that we compare this to the box plot, where we look at the temperatures for those without antibiotics. Here we can see that the median is pretty squarely between the first quartile and the third quartile, and the distance to the outlier boundaries are about the same. The distance to the upper outlier boundary is a little further out, which suggests some skewness to the right, but it's not very great. In general, these temperatures are a lot less skewed and much closer to being symmetric. I do see that I've got some outliers here, but it's the same number on the top and the bottom, so again that is suggestive of symmetry in this case. Okay, let's look at paired data. We're going to look at scatter plots and line plots. So I'm going to import some data about ozone measurements in Los Angeles in a recent year. Here the variables are day of year, which is 3 through 365. Apparently there's no data for the first 2 days of the year. We have the maximum wind speed in miles per hour, average percentage of humidity, the average temperature in degrees, visibility in miles, and an ozone rating. So let's read this data in and take a look at it. I can see my 6 variables here, and this is a fairly large data set. Let's attach this data set to our workspace. Now let's do a scatter plot. We've already used the plot command before, so let's use it to see if there are any trends in ozone based on the day of the year. I'm going to put in plot, and the first variable will be on the x-axis and the second variable will be the y-axis. So here I'll use DOY, day of year, for the x, and ozone rating for the y. I'll also use some of the options that we've seen before. The main title will be ozone levels in Los Angeles, the color will be light blue 4, and the point character will be 16, and I'll use a size 1.25. Let's take a look at it. One thing that we can see here is that it appears that ozone ratings are higher in the middle of the year. Remember that day 182 is approximately halfway through the year. Now instead of plotting points, we could have used a line graph. And we do this by using the option type equals lowercase l, and that's got to be in quotation marks. So let's see the line graph. And again, you can see the same pattern here, maybe even a little bit more clear with the line option. You could plot both lines and points. Here we would use the lowercase o as the type. Now another neat view is the histogram-like lines. And let's just take a look at this. We will use a lowercase h as the type. And again, you can see that this just provides another way of looking at the relationship between x and y. Suppose we want to know if there's any relationship between temperature and ozone. So I'm going to plot temperature on the x-axis and ozone on the y-axis. Here I'll use the color Orchid 4, and I'll put in some options for how the points will look, and I'll also put in some options for the x and y labels. It appears that there's a positive association between temperature and ozone. I'm not quite sure I would call it a linear association, but certainly it is a positive association. So that just about wraps things up, but I'm going to do one more graph. I'm going to use the R. Brewer palette here as my color option, just to spice things up a bit. So that brings our introductory lesson on data visualization to an end. There will be some other types of graphs that we'll come across in future lessons, but we'll work through the details of those when we get there.